Alright, hi guys, I'm going to go ahead and reintroduce this form I should say, since I've made quite a few updates to it. If you remember, this is the form where you take a pattern in terms of XZ data and you can generate looping Gcode to machine the pattern. It's predominantly targeted towards a nanotech 350, maybe a 650 FG. It may work on some of the other ones, but some of the G-codes may be relatively specific to those machines. But in any case, the way you do it, you input the X and Z position for your pattern over here, and you'll get a graphical representation here in the center. Once you have the data input into the control here, it doesn't really matter whether it's positive to negative or whatever, how you want to import it. You go to the parameter entry sheet here, and then you would specify the machining parameters you would want to machine, whether it's going to be a turning profile or a ruling with X, Y, Z. In terms of turning, you'll see that it changes surface speed and feed rate millimeters per rev. I plan to update that a little bit more options, whether you want to do millimeters per minute or millimeters per revolution, etc. And right now there is quite a difference. Don't have it updating. If you click from turning to ruling, the feed rate will still say 425 millimeters a minute. It's quite different than 425 millimeters per revolution, so that's something that I need to look at. But that should be a relatively simple change. So for this turning pattern here, if you were to say just specify, I have these parameters already pre-specified here. And what these parameters here, specifically the fixture height and the tool radius, there's multiple ways to set the zero on the machine. The way I'm envisioning with this particular program at the moment is you can set your Z0 either at the spindle face or on the face of your block. You guys at GA know what I'm talking about. And then you would just input your fixture height and the tool radius, and it would shift the Z using the G52 to be in the correct position. And then if you want to change the Z from that point forward, if you wanted to remove more material, for example, you just reduce this fixture height and it'll move the part in. That has the advantage of keeping track of exactly what the Z position is of the surface of the pattern with respect to the rest of your coordinate system. In terms of in the ruling here, there's a couple options I've added in terms of the y-axis, the part height. So if you had a rectangular part or even a cylindrical part, this would be the height of the part on the spindle as far as the y extent goes, how far positive and negative is the part's going to be. And then this y-axis extension is going to be how far to extend past that. So the part can have a little bit of room to clear the tool. This rough filter step over is something I've added because right now, as far as normally on your surface finish when you're doing two-axis turning, it's pretty much primarily governed by your feed rate and spindle speed, so your microns per revolution. And when you're generating the data with an equation, you can kind of specify your step over size. But the way this is going to work with a predefined array, this X and Z coordinates, is your surface finish in terms of y-axis planing is going to be defined by the spacing on your pattern. And ideally you're going to want that spacing to be pretty close together so you have a good finish, but that's not very advantageous for roughing because this small step over size is kind of unnecessary for the roughing machining passes. So what I've done is I've added a filter. So you just specify like a 30 micron filter, and it will increase the rough step over. It'll filter out some of this data here. So I'll show you real quick what I'm talking about. I have added some tool compensation options, G41 and 2, no compensation, and also computer comp. So without further ado, let's go ahead and generate a tool path here. So this should be, we'll do a simple two-axis turning path first. Okay, so this is what the toolpath looks like. You can see it doesn't waste any time cutting air, it just cuts the material very efficiently. And this toolpath here is going to take about at the feed rate I've programmed, it will be about 1 minute. Okay, so you can see about 14 cuts, 48 microns per cut. One is at my finish pass, one finish pass. Kind of gives the information here. The reason for this G52 here, this work shift I have, is because this is calculated from the center of the tool. So this is what the center of the tool is going to look like. Normally when you set your Z0, you want to set your Z0 with the tip of the tool, so this lets you go ahead and establish all your Z position datums with the tip of your tool, and then this pretty much behind the scenes, you don't need to worry about it. We'll shift the Z negative by that amount. For graphic purposes, let's see here. Okay, so go ahead and save this as a reference. Back here on this sheet, if I go ahead and I'll hit filtering's not really for the 2-axis turning, it's for the 3-axis. But so come over here to computer compensation. And now this, you see this said no comp. Okay, and now I went ahead and put this in here, and you can see the toolpath is compensated here to look like this. If I go ahead and take this shift out, you'll see everything shifted up that way, and then if I come right here, this is what, a 30 micron tool? Okay. What I'm doing right now is I'm just explain in a second. And this will now have a little graphic representation of what the tool is. So you can see it is tangent to the actual finished cut there. And let's take this same little snippet of code here, and paste it in right here. Let's just say right here. Go ahead and put it in right there. You see it's tangent to that blue cutting edge around all the way around the part, both on the roughing and the finishing. Okay, what I was doing with the yes. And what else? Okay, so let's go. That is the 2-axis turning. I'll go ahead and we'll take this out. I'll go ahead and skip the roughing and regenerate real quick. Okay. And that is the finish pass. Go ahead and save that as a reference. Okay, so what we'll do now is I'll step over to the ruling toolpath, and I'll go ahead and just keep just the finish pass real quick, just so you can see what that will look like. So you can see it follows the same profile as the other part. This will take considerably longer to cut, obviously, by nature of the toolpath. But if I take off the rough cutting here, and I'll explain what that does in a little bit. You can see, so this should do the same thing. And this program at the moment is going to take about an hour and a half with the current parameters that I have. And you can see the roughing. Planing looks like this. I should step over here now. Yeah, so it'll rough down like that, but like I said, the roughing is very fine right now. It's the same resolution as the actual pattern. So if we come over here and we go ahead and put the filter roughing on, and then regenerate that toolpath, and then paste that in. Now you can see it's a much coarser step over for the roughing, which will be considerably faster. which is 24 minutes instead of, what was it before, an hour and a half? So it's a pretty significant time savings. The other thing I've added to this is you can see right now the actual data was applied in terms of from x5 down to x0. So I went ahead and added this center line here for the y-axis, or for the x-axis when you're doing the y-axis ruling. If I were to just, that just shifts the pattern by that amount in x. So now when I paste this in here, it's putting the pattern 4 millimeters over here. And it's putting the center of the pattern. Well, this is putting the edge of the pattern at that. This shifts the whole thing by 4. It's doing that with the G54 right here, the G54X. So you can change that in the control right here to achieve the same result. Other thing I have added is if you wanted to center the pattern, you just click this and it'll center on the extent of the profile. So that is, I think, pretty much most everything I wanted to cover. There are a few quirks with the tool compensation at the moment. It won't be apparent on this specific pattern, but if I have, for example, if I had another pattern like a little tight sine wave, right at the very last data point, it might the slope might be slightly off. So either you would want to have the pattern extend out past the actual edge just to make sure it wouldn't be an issue. But other than that, I think it looks pretty good. Okay, thanks guys.